So in our previous video, we graphed average fixed cost. So we looked at how the fixed cost, that was our stapler, gets spread across the number of units produced, and so it continually declines. The average variable cost, that's the cost of the workers spread across the number of units, and that's going to be highly dependent on the productivity of the worker. So we see an average variable cost with a U shape because average product has the upside down U shape. When the workers are more productive, the cost of the worker gets spread across more units, making the average variable cost go down. When the workers are less productive, then the cost of the worker gets spread across less units, making the per unit cost go up. So we had our U-shaped average variable cost. And we know that average total cost takes the variable and the fixed, so it adds average fixed cost and average variable cost together. So it's getting pulled down by the fixed cost, by that great decrease in average fixed cost, and then gets pulled up by the average variable cost. So it also has a U shape. We are missing one more curve on our graph before we can start making decisions for our business about how much we are willing and able to sell. And so the last graph we want to look at is what is called the marginal cost curve. The marginal cost curve is the change. So remember this delta symbol, this triangle, this means delta, or is a math symbol delta, which means change. So it's the extra variable cost that we get when we produce one more unit. And that's because we're looking at the change in overall cost, and we know that fixed cost doesn't change. So it's really just the variable cost that's changing. So we look at the change in total variable cost divided by the change in output. So as we make more units, how much extra does it cost? So let's go back to our widget demo here. We have the change in total variable cost divided by the change in total product. Okay. Change in total variable cost divided by the change in total product. So here we're going to look at the change in our total variable cost. So we're going to go from having 0 workers to 1. So the change in total variable cost is that additional 5. Now there's nothing here, but when we add that change, we go from 0 to 1 workers, the change in total variable cost is 5. The change in total product, we go from making 0 units to 6. So our marginal cost here is 5 divided by 6. All right, 5 divided by 6. All right, 0.83. When we go from having 1 worker to 2 workers, our total variable cost goes from 5 to 10. So here we have an extra cost of that 1 more worker at $5. And our total product goes up by 1 from 6 to 7. So 5 divided by 1, which is 5. Then we go from having 2 workers to 3 workers. So we're paying an extra $5 for that worker. So the change in total variable cost is 5. And the change in output goes from 7 to 11, which is a change of 4. So 5 divided by 4, 5 divided by 4, we get our 1.25. Then we go from 3 workers to 4 workers. We pay $5 for that extra worker. And our output goes from 11 to 13, so that's a change of 2. And 5 divided by 2, which of course you can do off the top of your head or you can put into your calculator at 2.5. And then lastly, we go from 4 workers to 5 workers. It costs an extra $5 for that 5th worker. And the output goes from 13 to 15, which is a change of 2. So we're at 2.5. So let's look at our marginal cost numbers that we've just calculated, and let's put that on our graph. All right, so on the graph where we graphed our average total cost and average variable cost and average fixed cost, we're going to add our marginal cost. All right, so when we produced 6 units, our marginal cost was 0.83. That's right here. Okay, and then when we produced 7 units, it was 5. Okay, and then it went to 1.25. All right, at 11, it's at 1.25, which is less than the average variable cost, so it's down here. Okay, and then it went to 2.5. And let's just check here, which is above the average total cost. Okay, and then at our output of 15, it's also at 2.5, which is above where we were before. Okay. All right, so let's connect those dots. Woo. All right, we have a crazy looking marginal cost curve. So let's talk about why, and then we'll talk about the theoretical curve. Okay, so what we see with our marginal cost is first it went up, then it went down, then it went up, and in our case, then it was flat. So this is the extra cost to produce one more unit. Well, this is going to be dependent on how much extra is produced when we hire each additional person. So the marginal cost is going to be highly dependent on marginal product. So let's go back to our marginal product graph. So remember our marginal product graph, it went down. So in this case, when we hired that second person, we didn't give them a specialized task. We had them doing essentially the same thing as the other person. In the class demonstration, this one here, they're both folding. And so they're not doing unique tasks. So we had diminishing returns. Then when we hired the third person, we started divvying up the jobs. We had one person fold once, one person fold a second time, a third person staple. So we start to see those divisions of labor allow for each additional worker to add more than the person before. Then as we added the fourth worker, we gave the fourth worker a job similar to someone else. So we had then two people folding the first time. And what that does then is that's not an additional division of labor, another specialty. So we get diminishing returns because of the one stapler. And then you'll notice here we go from 4 to 5. That additional worker, when we add the fifth worker, they added the same as the person before. Okay, so notice that in this example, the marginal product went down, the marginal product went up, then it went down, and then it went straight. Well, the marginal cost is the extra cost to make a widget. So if the additional worker is adding less, then the cost now gets spread across less units, and so the marginal cost will go up when the marginal product goes down. So if the extra worker contributes less, then the extra cost to make that one unit is going to be more because it's going to be more of the worker, and that cost of that worker can't be spread across as many units. When the extra worker adds more to the production, then the extra cost of the worker, the $5 we're paying them, gets spread across more units. So the extra cost to make one more item will go down. So notice when marginal product goes up, marginal cost goes down. When we hire a worker and the amount they add is less than the person before, we're paying $5 for that extra worker, it gets spread across less units, so the extra cost to make that last widget is going to be higher. Got to have more of that salary for that worker built into less widgets, that one widget. And if the marginal product is not changing, then we expect the marginal cost to not change as well. So marginal product went down, up, down, and straight. So our marginal cost we should see should go up, down, up, straight. So did we get that? Let's go back to our graph. Up, down, up, and straight. So this marginal cost curve has this shape because our marginal product has the inverse of the shape. It goes down and then up and then down and then straight. So marginal cost is very dependent on marginal product. There's also a relationship between marginal cost and average variable cost. So if you recall our previous discussion, let's go back. Remember that there was this relationship between average product and average variable cost. So if there's this relationship between average product and average variable cost, and this relationship between marginal product and marginal cost, we also know there's a relationship between marginal product and average product. If the marginal is below the average, it pulls it down. If the marginal is above the average, it pulls it up. So that means that there's a relationship between marginal cost and average variable cost as well. So let's take a look at that. Okay, so notice, let's find a different color here if we can. So notice here, marginal cost is above the average variable cost. So the extra cost to make a widget is more than the typical cost to make the widget if we're looking just at the variable costs. And so if the extra cost to make a widget is more than the per unit cost, what is going to happen to that average? It's going to pull it up. Okay. And when the marginal cost is below the average variable cost, it's going to pull the average down. When the marginal is above the average, it's going to pull the average up. So this curve that we're seeing in our average variable cost is tied to what's happening to the marginal cost. If marginal is above the average variable, it's pulling it up. If marginal is below the average, it's pulling it down. Okay. Perhaps we can see it a little bit cleaner with our theoretical graphs. When you graph the marginal cost curve, it looks like this. Oops, I missed. Let's try that again. The marginal cost curve looks like a check mark. It goes down and then it goes up. And the reason the marginal cost curve looks like a check mark is because marginal product goes up and then down. So we get divisions of labor. Everyone has a different unique task, which means collectively we are able to make more than individually, so each additional worker adds more than the person before, which means the extra cost to make one more unit goes down because as we add each additional person, we're getting more and more out of them. So we can take the costs and we can spread them out. So marginal product goes up, marginal cost goes down. Then we hit that point of diminishing returns. Because we have that fixed factor like a stapler, we can't keep adding different jobs, right? So let's say that we're producing widgets. We start out with divisions of labor. I fold once, you fold twice, somebody else staples. Maybe we have a fourth person who feeds into the stapler. We have 4 different jobs. But if we add person number 5, then we're starting to duplicate work. And the person who's stapling still can only staple so many times. So as we add person number 5, person number 6, the problem is now we just have more people folding. Well, if there's 3 of us and we're all just folding the piece of paper once, then what's happening is we're just accumulating a huge pile of folded paper, and the person who is stapling, that's a mouse, not a stapler, the person who is stapling can only staple so much, right? So then we start to see that diminishing return. So this is what we were talking about before in terms of the law of diminishing returns or diminishing marginal product. We keep adding jobs, we keep adding workers, but because of that fixed factor, we are increasing our output, but at a slower and slower rate. And so if we go to our graph, we start to see that marginal product fall. Each additional worker is adding less. Now, total product, you'll recall, is still going up. We're still making more, but at a slower and slower rate. So the extra cost of those workers, in this case the $5 we've been looking at, gets spread across a lower and lower amount of units produced. And so the extra cost to make one more unit goes up and up as we get less and less out of each additional worker. So the marginal product falls, the marginal cost goes up. We get this check mark shape to marginal cost. And because of the relationship between averages and marginals, you can see here that the average variable cost is at its lowest when it intersects marginal cost, because if the marginal is below the average, it pulls the average down. If the marginal is above the average, it pulls the average up. The same thing is true for average total cost. If the marginal is below the average total cost, it pulls it down. If the marginal is above the average total cost, it pulls it up. Marginal cost is not impacted by average fixed cost. Average fixed cost is not impacted by marginal cost. And that's because fixed costs are fixed. Marginal cost is the extra cost to produce one more item, and fixed cost doesn't change when we produce one more item. It's fixed. So when we look at marginal cost, remember marginal cost is the change in total variable cost divided by the change in output. You could also measure it as the change in total cost divided by a change in output, because the only part of cost that changes is the variable costs. So we have this relationship between marginal cost and average variable cost, and we have this relationship between marginal product and average product. So we can see on either graph where we're getting the most per worker. So that's here where average product is at its max. We're getting the most per worker. And we can figure out what quantity of units where we're also getting the most per worker. One showing cost, one showing the quantity of output versus the quantity of labor. So these points coincide with each other. So there's a relationship between these graphs. They impact each other, and it is these relationship between these graphs that are going to help us solve the question of how much are we willing and able to produce. We're going to look at the relationship between these curves in our next video, and then we'll start to put together that final decision about how much we're willing and able to sell.